Quick introduction for everyone. I don't know how many of you have just joined us or been here for the talks this morning. So our next speaker is Rachel Hersey. She's been part of Henkel for 21 years, based in Dublin, and has been part of Henkel's 3D printing team specifically for over 6 years. Her current role is as a product development specialist. And today we're going to be hearing from her about durable materials for 3D printing of industrial parts. Very quick reminder to everyone, we have the Q&A function, so you can type questions for Rachel in there. When we get to the end, I'll kind of filter some of those through to her. And hopefully if you don't get a chance to have your questions asked or answered, you can speak to her perhaps during one of the network sessions or contact her afterwards. But for now, over to you, Rachel.
Excellent. Okay, so as I said, my name is Rachel Hersey, so I'm really glad to actually be here today to actually talk. So as my title of my talk then is Durable Materials from Loctite 3D. So I'm just going to talk kind of how these materials are enabling 3D printing of industrial end use parts. So just a little bit just about myself. So I've been with Henkel for 21 years. I'm a chemist by qualification. I haven't always been a product development chemist, so I started as a lab technician in the research and development lab in the adhesives technology. So then I was eventually promoted to research chemist for adhesives technologies, and I worked on that for 15 years. And then I became a 3D chemist for resin development. So I'm there now 6 years to date, up until today. So my expertise then, my background includes, because I've worked in adhesives, it's obviously acrylics, and particularly cyanoacrylates, UV cure acrylates, epoxies, and of course 3D printing from my last few years of. So
Rachel, I'm sorry to interrupt you. Your screen is not, your slides are not moving on your screen. You might need to go to full screen on it and then flick through.
It's on full screen.
If you go into, are you in slideshow mode?
Yes. So you can only see my first slide.
Yeah, I can still see your first slide there.
Okay. So can you see this now? Can you see my screen at all?
Now I don't see your screen at all. I do have because I know you sent your slides through in advance. I do have them up on my screen, so I could try sharing that, and you just say kind of next slide, please, if that would.
Okay. If you want to do that. Sorry about that. I don't know why, because it worked there the last time, so we can try that.
Yeah. Let me see.
Sorry, everybody.
Don't worry, it happens certainly during these things. Just give me 2 seconds to get that up. So if I move to can you just tell me if that's moving between the slides?
Yeah, it's moving, yeah.
Okay, perfect. So if you just tell me when to move on to the next slide,
no problem.
Perfect.
So as I said, so I was just explaining there just a little bit about my background. So as I said, my expertise includes acrylics, UV cure acrylics, epoxies, and of course 3D printing. And so I developed a lot of products over the years for both adhesives and some for 3D printing as well. And I'm also an inventor on 12 patents. So, I mean, being part of a research group is always kind of, there's always an opportunity to patent your work. So, and in Henkel, we're quite active at patenting work. So it's quite nice to be involved in that. So, so if you go on to the next slide then, please, for me. Yeah, so basically the 3D printing technologies that Henkel are involved in is basically the liquid UV cure resins. So the DLP and for SLA. So I think you'd kind of ask the question, like, why would Henkel get, because they're an adhesives company, why would they get involved in this kind of industry? So basically it's because of our background, particularly in the UV acrylic. So we have a lot of expertise in UV acrylic chemistry from the adhesives. So it was kind of an overlap there that we saw there was an opportunity that we could actually, with our material science background and our background, we were able to kind of say, okay, well, there's actually an opportunity here to kind of break into this industry, and we can actually bring some value with our some of our materials that we could possibly bring to the table. So the next slide, please. So as I said in the title, we were just talking about like 3D printing for production. So I think it's nice to just go over kind of like what we think the key benefits of 3D printing for production are. So I think a lot of us on this call would kind of know this, so it's no harm to kind of go over it and emphasize it. So things like customization and low waste and tool cost, lightweighting, decentralizing your manufacturing as well, faster time to market, which is very important and a very big advantage, and complexity and design freedom. So kind of obviously we know that there's certain things that we can make with 3D printing that we actually can't make with conventional tooling. So the polymer 3D printing mainly at the moment is used kind of prototype parts produced for form, fit and function testing. It's not widely used for end-use production parts at the moment, so there's kind of challenges there. There are some things that, kind of stop this from happening. So if you go on to the next slide for me there, Candice, we find out. So the challenges then, what are the main challenges? Okay, so the materials in general, they're often limited to a small range of options. The materials, they're not meeting requirements for end-use applications a lot of the time, and the materials are often not durable enough for long-term use. So having access to these types of materials, durable materials in particular, so this will bring 3D printing into the next phase, where parts won't just be used for prototyping, they'll also be used for industrial use. And another kind of challenge that we also see that I just didn't put on there is there's kind of a limit to kind of data as well that's available for materials out there for customers and for people using it. So I think that's also a blocker. So people kind of, they have these materials or they see these materials, but they don't really know what they can do. They don't really know what that they can bring to their industrial process. And I think that's also kind of a blocker to the adoption of 3D printing for industrial use as well. So if we go on to the next slide, please. Okay, so durability then. So where does the durability matter? Okay, so for printing end use parts, so we're going to sometimes be using them outdoors, and some will be used indoors, some will be used in industrial settings. So it's very important to kind of target the type of testing that we do on our materials and to gather this information so we can actually find out what materials or where the materials can be used. So for outdoor use, kind of the testing that's important that to do would be things like UV exposure, heat testing, humidity testing, accelerated weathering testing, that type of thing. And then for indoor use, things like fatigue testing, that it's going to have parts that are under like constant loads or changing loads, and also temperature and chemical resistance if they're going to be kind of in an industrial type environment. So it's very important to kind of target your testing to where you think the end user is going to want to use these materials. So if you go on to the next slide, please. Okay, so just a little bit about the durability in general then. So most standard resins, they're not recommended for stressed parts or outdoor use. So why is this a lot of the time? So okay, so from a UV standpoint, or say an outdoor in the sun standpoint, like the resins, they're reactive to UV exposure because that's how they work, that's their chemistry. So it means that when they're exposed to sunlight, like this causes them to be exposed to more UV radiation. So a decrease in performance happens, and also a decrease in the appearance of your parts. So what's happening on, say, a kind of from a chemist point of view, what's happening on the polymer level. So the process of photolysis, it degrades the backbone of the molecule, basically. So this in turn reduces the molecular weight of the polymer. So this can cause the properties to decrease. So things like your strength, your ductility, all these things kind of decrease when this degradation happens of the polymer. So basically, you can also get a decrease in the aesthetic of the polymer. So that means that your color and your texture start to change. So this manifests itself in the parts as a decrease in elongation in particular, and also an increase in yellowing. And you'll see this particularly in a clear part. If you've got clear parts and maybe parts that are kind of a white color, they might start going yellow, or they will start going yellow in UV exposure. So for elevated temperatures then, so there's different types of degradation that can occur from this reaction. So the side group elimination, like random scission, and also depolymerization can happen. So this destructs, again, the backbone of the polymer, resulting in these property deficiencies that we see. So there's also thermal stresses that can happen in the polymer when you expose it to high temperatures, in particular, outgassing, and these can cause cracking and stuff like that, and warping. So in the parts, we'll see warping, cracking, brittleness in particular, and decreased strength and elongation. So these are the things that stop, as we said, stop some of the polymers being used in some of these environments, because like this is how they age over time when they're exposed to these environments. So if we go on to the next slide, please. So for humidity, then this is obviously important, again, as we said, for these outside environments or high humidity environments that your part might be used in. So we get, again, on a polymer level, we get reactions happening, so particular hydrolysis. Again, it's a degradation reaction. So, and obviously the more moisture is there, so the higher your humidity, the faster these reactions can happen. Also, solvents is a very important thing, because if it's being used in industrial environments, for example, it'd be exposed to chemicals, it could be exposed to things like oils, it could be exposed to various different things. So, and also your washing cycles, like you have to be very careful if you're using, say, an alcohol wash or different types of washes. It's very important that you need to test these environments as well, because this can also be damaging your polymer. So basically, the solvents over time, they can break down the polymer. They can also dissolve the chemical bonds of the polymer. So again, this leads to the breakdown of the polymer, which leads to decreased properties. And exposure to water and solvents in for 3D printed parts, that can manifest itself as swelling, plasticization, and reduction properties as well in particular. So these are kind of the main areas that we would be testing for, or that we should be testing for, when we're testing durability of our polymers. So if you go on to the next slide, please. Okay, so Henkel then. So what is Henkel doing in this area, when we're talking about our resin? So product development, so our chemists, our resin development people, part of my team. So we have a formulation strategy and aimed at taking the main mechanisms of degradation, say stuff that we just talked about in the previous slide, to try and improve the current and future resins. So that's one aspect of what we're doing. And also, we're acquiring knowledge by intensive testing of our current resin formulas that we have on the market. So basically what we're doing is we're taking all these important areas of testing, and we're extensively testing our resins for our TDSs. So gathering this data so we can provide this to the customers, and also to our partners that we work with, and also to the PD team. So all of this data is shared, so it can provide information on what the polymer can currently do, so we can make a choice of where, the customer can make a choice of where they can use it, and also for us to know the limits of the polymer so we can actually make better polymers. So if you go on to the next slide, please. Okay, so I'll just talk a little bit, I'll just give an example of a proof point. So this is one of our products, Loctite 3D 3843. So this is we would say this is one of our best selling products. It's an ABS type product. So basically this is the first one that we've done our full suite of testing on, and we have published the TDS with all of the information on. So that's just basically a summary of the properties. So if you go on to the next slide, please. Okay, so as we said, we believe knowledge is power. So in our TDSs, we share all the data about material durability testing. So heat aging, we've done accelerated weathering testing, we've done chemical resistance, and also we've tested at different temperatures the performance of the material. So by using this knowledge sharing, as I said, it allows the partners that we work with and our customers to make an informed decision, obviously, on where they're going to use the material, because they have all the information of the capability of the material by the information that we share on our TDS. So I think by this, we're kind of setting a new narrative for transparency. So I think, as I said at the beginning of the talk, sometimes one of the blockers for the adoption of AM is the lack of data available on a lot of the polymers. So by sharing all this data on our TDS, people can make an informed decision and a better decision on where to use the parts, and that can lead to, the adoption of AM, because people know that they're going to use a material that's actually going to work in their application. So if you go on to the next slide, please. Okay, so just an example of a performance of this material in the real world. So we have a lot of different use cases, but this is actually a really good one. So this is a company called KTM. So they're an Austrian company. So they used a Genera printer and obviously our Loctite 3843 material. So it's basically a clamp for the suspension of the bike, so you can see it there. So this part, they didn't want to use injection molding for this part because of the expense, basically, and because it was a short production run and they wanted to kind of iterate fairly quickly. So AM was actually perfect for their production process for this, but they wanted the right material. So so basically, it's they use it. It can withstand, because of the data that we shared with them. They knew that it could withstand the correct temperature range, and it had the correct material properties. So they ended up using it. So it ended up being IMDS registered, and what IMDS is, it's the International Material Data System. So it's basically the automotive industry's material data system that all the OEMs use globally. So once it's registered on this, it means that it meets certain specs and standards for that industry. So so basically, the part that was designed, so it was one of the first AM made parts with polymer that has been registered on this. So I mean, it kind of gives very good visibility then to AM, photopolymer AM in particular, for using for end use parts. So that was quite good. So as at the bottom there, so if you can actually search for this case study, if you go 3D printed suspension clamp on YouTube, so you can learn a bit more. There's some video there that you can watch, and also we have a brochure published on our website as well for our materials on this case study in particular. So if you wanted to learn more about any of the about the material itself or about the use case, you can go ahead and do that there. So if you go on to the next slide, please. So then just a summary, just a little bit about kind of what I talk about to summarize. So as I said, there's a need for material performance data in various environments. So I think when we're talking about durability, we need to choose, we need to pick we need to test, first of all, our material fully. We need to pick which environments we know are important for that type of industrial use or outdoor use. We need to test it. And then we need to be able to be transparent with our data with customers on our TDSs, so they know that you can use this material for that application. Because a lot of the times there's no data available, or customers don't know where to get the data. So I think that needs to be kind of clearer. So I think we're driving the industry in this way by continuously testing materials and providing the data to customers and partners so they're able to make these decisions. So we're developing the next generation of resins to improve durability in a range of different environments by using our expertise and our knowledge and our good teams. And then I think we're driving the AM industry. So I think the whole industry needs to start doing this. So we need to provide more transparency to realise the dream then of transitioning from prototyping to full value industrial production, because that's where the next step of where AM should be. So if you go on to the next slide, please. So let's stay connected. So if you want to learn more about our photopolymer resins, please go to loctiteam.com. We have all of our TDSs and our full portfolio of resins on there. We also have workflow validations for a number of different printers. So if you want to learn more about Loctite 3043 that I talked about, or any of the other resins and what printers they're compatible with, .com. There's also a lot of case studies of different resins of actual real use cases on there as well. And if you have any questions and queries, you can either get on to myself, or you can go on to the email on the website there. So thanks for your time, and thanks for helping me out on sharing, Candice. So that's me. So if anybody has any questions, I'd be happy to take them. Thanks.
That's brilliant. That was great teamwork,
Thank
I think. That was lovely. I'm always really excited to hear companies talking about being more transparent with data, because actually you said something about how having all this data really helped you to develop better materials, but it also helped people to use them better. And to me, that sounds like a massive win. We have a couple of questions in the Q&A, so I'll just go straight to those if that's okay. Question there about whether you do material testing after building the parts, so testing on the parts themselves, but how you deal with differences with AM machine manufacturers.
So basically, I think I understand the question. So basically, when we're developing the material, we would use obviously the ASTM standards for the plastics. So that would be, say, the standard test parts, like the dog bones, the bars, the flex bars and stuff like that. So that's how we develop our resin. So we would use those tests as the standard for those. But if we're working with a customer in particular that has a particular part that they want to print and they want tested, then we work with them to test the end part that in their environment. But when we're developing, we use the standard, and then obviously if there's a particular part to be tested, then we would work with the customer on that to try and help them, or to try and give them advice on how to test the parts. So it's kind of we do test some end parts, but it would be with the actual end user in that case. So when we're developing, we would use the standard ASTM type parts.
Perfect. And another question, which actually I had a very similar question noted down, so I would have upvoted this if I could, because you were talking about developing materials and properties that are needed and everything. So a question here really about, is it better to develop materials for specific use cases, or do you prefer to develop general materials that might benefit a range of industries? And I'd possibly add on to that, how much consultation is there with different industrialists? Do you speak to some people and they say, we need a material that does this, and you go ahead and develop it?
Yeah, that's a good question. So we develop resins that we kind of sell as a kind of general, so we make the best resin that we can, so like Loctite 3043, so that could be sold to, it works on a lot of different printers, it's a very good material, but it works in a lot of different environments as well. So we kind of use that and work with a lot of partners with the same resin. So we do that to sell that as a general. But also if a customer, one of our OEM partners comes to us and says, okay, we want a very specific resin that does this, this, and this. So then we sit down with them, we make a what we call like a profile, a material profile, what they want. Then we will work with them on a specific project to make a material for them to sell specifically with their printer. So we do both. So we have, but then that would be so we wouldn't be selling that then through the general channels. So that would be just a specific material. So our PD team has worked on lots of different projects. So both with specific projects for one customer, or basically the general products like in our portfolio. So yes, we do both. So we work very closely with our partners. So when they work with us, they get our team, they get a team, they get a project team, they get a project timeline and everything. So we do work very close with them to make the materials that they need.
Mm-hmm. Sounds like a fascinating role. I love hearing people present and thinking, yeah, I could enjoy that job.
Yeah, it's good. Keeps me on my toes.
Mm-hmm, good. Very quickly, are you around for any of the day in any of the networking sessions?
I have to head into the office now, so I might hop in later on, maybe for some other talks and stuff like that. So I might be around later, but not immediately after this call.
Okay. Yeah. So if people are around later on and want to catch Rachel and you see her going through questions, I might do the same because I had loads of things I wrote down. As I said to the previous speaker, normally we'd have a round of applause at this point. I thought that was super fascinating. I'm going to send you back to the floor and bring up our next speaker now. So thank you very much, Rachel.